Welcome to the fourth episode in our series where we create a 3D rendering engine. In this episode we'll be preparing for textures, and our end goal is to make something that looks like this. So I can move around and view it from different angles, and so our program will take an object file and a texture file and render it from those two things. So last time we wrote this little piece of code, our applied transformations code. This time we'll be preparing for our texture drawing code. So up here we're going to create two new variables. We're going to write public int screen width and public int screen height. Then down here inside of our form 1 we're going to write screen width equals this dot width for now, and screen height equals this dot height. We will change this later, this is just temporary. Then down here we're going to write bitmap frame buffer equals new bitmap, and then here we'll write screen width and screen height, and then we're going to write byte, make an array, and we're going to call this pixel buffer equals new byte array, and inside here we're going to write frame buffer dot width times frame buffer dot height times by 4. We times it by 4 because each pixel has a red, green, blue, and alpha value. Then down here we're going to write float array, but put a comma in here for x and y. This is going to be our depth buffer, and we write equals new float frame buffer width, comma frame buffer height. And then here we're going to write object and do the same thing, and we're going to call this depth buffer lock, and it'll be equal to new object frame buffer width frame buffer height. So the frame buffer will store our final picture, our final bitmap to be drawn to the screen. Our pixel buffer will store each pixel in a byte array in order to be written to the frame buffer. Our depth buffer stores how far away each pixel is from the camera. And our depth buffer lock is used, later on we'll be adding in the usage of multiple CPU cores, and if both two CPU cores are trying to access the same pixel, it can create some glitches. So the depth buffer lock almost ensures only one can access each pixel at a time. And then we're going to write here for int x is 0, x is smaller than frame buffer width. We're going to do the same thing for the y value. So put a y here, a y here, and a y here, and make this height. And then inside here we're going to write depth buffer x comma y equals float dot positive infinity. And so this is going to set each of these values to the biggest number it can be, so that when we go to draw the pixels, any empty spaces will be just treated as super far away into the distance, so it can still be drawn to. And we'll do the same thing for the depth buffer lock. It'll be equal to a new object. and then down here we're going to write bitmap data frame buffer data equals frame buffer dot lock bits new rectangle 0 0 frame buffer width frame buffer height, and then here we'll write image lock mode dot write only, and pixel format 32 bpp ARGB. And so this is going to lock our frame buffer so that it can only be written to. Down here we'll write marshal.copy pixel buffer 0 frame buffer data dot scan 0, and then we'll write pixel buffer dot length. And so this is going to copy what's in our pixel buffer to our frame buffer, and then we'll write frame buffer dot unlock bits to unlock it again so that we can access it. And so here we're going to write e.graphics.draw image frame buffer new rectangle 0 0 this dot width this dot height, and we'll write new rectangle and then 0 0 frame buffer dot width and then frame buffer dot height. And so this is going to draw to the size of the screen our frame buffer, and in here we're also going to write graphic unit pixel, and then finally we'll write frame buffer dot dispose, so we'll get rid of it because we'll create a new one when we draw the next frame. Now we can also create another variable at the top. We'll write public bool nearest neighbor, and we can actually make this true for now. And what this will do is we'll create down here a little if statement right here. If nearest neighbor, what we'll do is we'll write e.graphics.interpolation mode equals system.drawing.drawing2d.interpolation mode.nearest neighbor. So what this means is it will make our pixels sharp. So say we were rendering at a low resolution to the actual image size of the window, then what will happen is sometimes it will blur out the picture and sort of smoothen it over. And so we're adding a little check to say, do we want it to be sharp, do we want it to still be like a pixel, or do we want the program to smoothen over the image? So that's it for this episode. If you run the program, you'll notice that there's not much change to it. That's because we haven't really done anything yet to this main code that actually draws triangles, but we've just prepared our code for when we do add the logic of drawing each pixel on the triangle and texturing. So in the next episode we will be adding that, and we will already have the buffers to write to. And because we've written this bit of code over here, it means when we do go to test it next episode, we'll find that the image is already drawn to the screen, because this part of the code is already drawing this image to the screen. It's just that this image is empty, it's completely transparent. So when we do draw to this image, we will find that it will appear on the screen. And so over here, this is the code that we will be writing in the next episode. And and this actually uses our buffers to draw to the screen. So we'll add this bit in, and you can see up here with our draw triangle, instead of just drawing a blank triangle, a red triangle, we'll actually draw a triangle using this bit of code, which will also draw the texture. So that's what we'll be adding in the next episode.